Hello student, Hare Krishna. Today is my fourth video. In the last video, we have studied about the chain rule. But the chain rule, it is very vast. In the last video, we have seen that we have done the problem on what here three formulas. That is ddx of x to the power n, that is the power formula. Second, we have studied ddx of root x, and the third one, that is the ddx of 1 upon x to the power n, isn't it? Again, I will take the more and more problem on the chain rule so that you get perfect in the chain rule, and the whole chapter you can solve with the help of a chain rule, because again and again I am going to tell you that is the chain rule, it is the soul of derivative. Unless and until you don't know the chain rule, you can't solve any problem of the derivative, isn't it? तर विद्यार्थ्यांनो, हा इतका जास्त इम्पॉर्टंट आहे चेन रूल की तुम्हाला झोपेतून उठून कुठलेही प्रॉब्लेम विचारलं तरी आलं पाहिजे, कारण चेन रूल इट इज अप्लिकेबल फॉर द एव्हरी डिफरंट टाइप ऑफ ए फंक्शन्स, because we have to find out the derivative of a so many type of a functions, isn't it? Therefore the chain rule, that is the basic one, and once you know the chain rule, you can do the any problem of the derivative. So you have to take that chain rule very seriously, isn't it? Again I will take the problem here continuing the chain rule. So chain rule again. Chain rule, see, you know ddx of sin x. What is the derivative of a sin x? Cos x, right? But here, if your function it is like this, ddx of sin root x, isn't it? How will you find out this again? Again, in the chain rule, we have to do the two things. Once you have to put u so that your function get converted into standard formula, so as to find out the derivative. आपण काय करतो, u ठेवतो, u ठेवून एकदा डेरिव्हेटिव्ह काढतो, आणि u कशासाठी ठेवतो आपण? टू कन्व्हर्ट द फंक्शन इनटू स्टँडर्ड फॉर्म. जोपर्यंत तुमचं फंक्शन स्टँडर्ड फॉर्ममध्ये येणार नाही तोपर्यंत आपण डेरिव्हेटिव्ह काढू शकत नाही. साइन एक्सचे डेरिव्हेटिव्ह माहिती आहे, पण साइन रूट एक्सची माहिती नाही. देअरफॉर रूट एक्स यू हॅव टू सबस्टिट्यूट ॲज अ यू, इजंट इट? मग u ठेवून एकदा डेरिव्हेटिव्ह आणि u बरोबर जे आहे त्याचे डेरिव्हेटिव्ह. देअरफॉर हिअर यू हॅव टू सबस्टिट्यूट u. साइन u चे डेरिव्हेटिव्ह काय ते कॉस u, cos root x, and again you have to consider ddx of root x, right? Again cos root x, and what is the derivative of a root x? That is 1 upon 2 root x, isn't it? Second one here, say ddx of sin of log of, suppose I take the mixed function again, three functions, say sin, log, tan. Sin, tan, these are the trigonometric. Again logarithmic, that is the logarithmic function. Again see here, what you have to do? This total log of tan x you have to substitute as a u. Sin u चे derivative again you can write as a cos u, means cos of log of tan x. झालं, u ठेवून काढली. Again what is u? Log of tan x. Therefore ddx of log of tan x. See here, right? Again this you can write as a cos of log of tan x, remain as it is, right? Again you have to substitute u. See here you have to substitute u. Log x चे derivative 1 by x, but here that is the tan x. Log u चे derivative 1 by u. 1 by u means 1 upon tan x, right? Here you have substituted u. Therefore again ddx of tan x, right? Now cos of log of tan x divided by tan x, and here what is the derivative here? Sec square x, right? In this way again you can find out the derivative of the function, that is the function that is what here sin x, but I have take that sin x I have converted in the composite form, isn't it? त्या sin x ला काय केलं आहे मी? मिक्स केलेलं आहे. sin of e to the power x, sin of log x, right? sin of root x, sin of log of tan x. In this way you can mix the function, you can prepare that function in a composite form, and you can find out the derivative with the help of a chain rule. Again I will take the third problem here. See here again I write ddx of sin of cos square x square. See Here again, see. Again, if you observe this is again u. Here you have to substitute u. Sine of whatever there is, sineच्या समोर जे काय असेल पूर्ण, that is you have to consider as u. Isn't it? Sin u चे derivative means sin cos square x square. You have to substitute as a u. Sin u चे derivative cos u means cos of cos square x square. Again, here you have to consider d dx of what is u? Cos square x square. But this you can write as a cos x square whole square. See, याला असं लिहिता येईल तुम्हाला. Now again, cos of cos square x square. Here again. Here you have to substitute u. See, again you have to use the power formula. X to the power n. U square चे derivative. इथे काय येतं u पूर्ण ठेवायचं. U square चे derivative 2u means 2 cos x square. Again d dx of cos of x square. See here. Here you have substituted u. U square चे derivative 2u means 2 cos x square. Again d dx of cos x square. Again cos of cos square x square. Here 2 cos x square. Again you have to substitute u. Cos u चे derivative minus sin u means minus sin x square. And here what is the derivative of again x square? That is equal to 2x. Again d dx of x square. Right? Now again you know the formula. See here 2 sin x cos x. I have already told you this formula. 2 sin x cos x, that is the formula of a sin 2x. Suppose in case of this, suppose 2 sin x square and cos x square, then the formula becomes sin of 2x square, right? Therefore, in place of 2 cos x square, sin x square, you can write as a, and this minus sign you can write like this here, minus cos of cos square x square. Here again, 2 sin x square cos x square. This you can write as a sin of 2x square, right? And here again 2x. This is about the chain rule, isn't it? So, sin of cos square x square. See, the lengthy function, it is a very lengthy function and you have to find out the derivative of such a function with the help of a chain rule. Again, I will take one more problem. See, sin of, suppose, x e to the power x, right? See, very simple again. Where you have to substitute u? X e to the power x is equal to u, right? Again, this you have to substitute as a u. Sin u ची derivative cos u means cos x e to the power x. Again, d dx of x e to the power x. Here again, you have to apply which rule? Chain rule. Here again, you have to apply here the chain rule, that is u, you have substituted sin u चे derivative cos u. Again, cos of x e to the power x. Now here you have to apply the product rule, because here x and e to the power x, this is nothing but the product of a two function. Again, what you have to do? X remain as it is. The derivative of e to the power x, e to the power x. You have to give the sign plus. Again, e raised to x remain as it is. And what is the derivative of x? That is equal to 1. Right? Very simple one. Again, d dx of sine of tan of e to the power x. See, again where you can substitute? Here tan e to the power x, you can substitute as a u. Sin u चे derivative cos u, cos of tan of e to the power x. Now again, u ठेवून काढलं, again d dx of tan of e to the power x, right? Now cos of tan of e raised to x. Here again you have to substitute e raised to x is equal to u. Tan u चे derivative sec square u means sec square e raised to x. And what is the derivative of again e to the power x? E raised to x चे derivative e to the power x, isn't it? Again I will take one more problem. See here. d dx of sine of cos of 1 by x. See, right? Now see, what can you do? Again, again this you can consider as a u. Sin u ची derivative cos u means cos of 1 by x. Here again d dx of cos of 1 by x. Now here cos of 1 by x. Again, where you have to substitute u? Again 1 by x, it is equal to u. Cos u ची derivative again minus sin u means minus sin 1 by x. Right? Again you have to write in this bracket here. And d dx of 1 upon x. Right? Again cos of 1 by x. This is minus sign you can give here. Sin 1 by x. And again, what is the derivative of a 1 by x? We have to apply the rule. 1 upon x to the power n. What is the derivative of a 1 upon x to the power n? Minus n divided by x to the power n plus 1. Here what is the power here? 1. Means minus 1 divided by x to the power n plus 1 means 1 plus 1, 2. Therefore here minus 1 upon x square. Now again if you observe this minus, minus plus, therefore cos of 1 by x, sin of 1 by x, and again minus 1 upon x square, because minus get cancelled, isn't it? So in this way you can do the problem on what here? Chain rule. And here I have taken the formula, that is d dx of sin x. How many total functions are there trigonometric? 6. तर त्या 6 फॉर्म्युल्यावर सुद्धा याच टाईपचे गणित आपण करू शकतो. नाउ टेक अनदर फॉर्म्युला. सी हियर d dx of cos x. What is the derivative of a cos x? Minus sin x, isn't it? Now here I consider, see, suppose the first example I will take here, d dx of cos of x root x, isn't it? Second example, d dx of cos of log of 4x. Third example, d dx of cos of sin square root x. Again fourth one, d dx of cos of e to the power root x. Again fifth one, d dx of cos of log of tan of log x. See, I will take the 5 problem. Very simple again. Again, substitute u, find out the derivative. Substitute u and find out the derivative. Isn't it? u ठेवून एकदा derivative आणि u बरोबर जे आहे त्याचे derivative. Right? Now here again, d dx of, say, cos x into root x. What is the power of x? 1. And here what is the power of x? 1 by 2. Therefore here you have to write x to the power 3 by 2. Isn't it? Now don't apply here multiplication rule. Isn't it? Because both the terms are same. This is also x and this is also x. But this x, it is in the form of a root. Therefore, when the base is same, you can add indices. Therefore, consider this function as a x to the power 3 by 2. Again, substitute u. Cos u ची derivative minus sin u. Minus sin x to the power 3 by 2. And again, d dx of x to the power 3 by 2. Minus sin x to the power 3 by 2. And what is the derivative of x to the power 3 by 2? 3 by 2. X to the power 1 by 2. Power formula. This is the solution of a first example. Again, see the solution of a second example. d dx of cos of log of 4x. Again, very simple. Log 4x, you have to consider as a u. Cos u ची derivative minus sin u means minus sin log of 4x. Here again, d dx of log of 4x. Right? Again, minus sin log of 4x. Here, again substitute 4x as a u. Log u ची derivative 1 by u means 1 upon 4x. And again, what is the derivative of a 4x? 4x ची derivative 4. 4 get cancelled. This is the solution of a second one. Right? Simultaneously you can write the solution, you can write the problem also, you can do the problem also, isn't it? So you can catch my speed and simultaneously you can do the problem with my speed, isn't it? The third one, that is ddx of cos of sine square root x. See, sine square root x, the third, the solution of a third problem. Again this you have to substitute as a u. What is the derivative of a cos u? That is minus sine u, minus sine square root x, right? Again ddx of sine root x whole square. हे असं लिहिलं सो ॲज टू सबस्टिट्यूट यू, इजंट इट? नाहीतर असा गोंधळ होतो, कुठे यू ठेवायचं, रूट एक्सच्या ठिकाणी यू ठेवायचं की कुठे यू ठेवायचं, राईट? म्हणून याला काय केलं आपण, साइन रूट एक्स होल स्क्वेअर. अगेन मायनस साइन स्क्वेअर रूट एक्स remain as it is. Again where you have to substitute u, sine root x is equal to u square चे derivative 2u, 2 sine root x, right? Again ddx of sine root x, right? Now minus sine square root x, here again 2 sine root x, here again you have to substitute u. What is the derivative of a sin u? That is equal to cos u, cos root x, and the derivative of a root x, that is equal to 1 upon 2 root x. Again 2 sin x cos x. See here again the formula 2 sin x cos x, it is equal to what here, sin 2x. Therefore 2 sin root x cos root x you can write as a sin 2 root x, isn't it? Therefore in place of this 2 sin root x cos root x you can write as a sin 2 root x, isn't it? Therefore minus sin square root x, here you can write here sin 2 root x and divided by 2 root x, isn't it? This is the solution of a third problem, right? Have you got the idea? What you have to do? First substitute u, find out the derivative. चेन रूल, त्याचं नावच काय दिलेलं आहे, चेन रूल. एक एक चेन आपल्याला सॉल्व करायची आहे, एक एक चेन, एक एक कडी आपल्याला काढायची आहे. काय ठेवून? यू ठेवून, राईट? यू अशा ठिकाणी ठेवायचं सो दॅट युअर प्रॉब्लेम शुड गेट कन्व्हर्टेड इन टू स्टँडर्ड फॉर्म्युला, isn't it? Now again the fourth one, see the solution of a fourth problem. See here, that is ddx of cos of e raised to root x. Again very simple, e raised to root x you have to substitute as a u. Again cos u चे derivative minus sin u, minus sin e to the power root x. Again ddx of e raised to root x, right? Minus sin e raised to root x. Here again you have to substitute u. E to the power u चे derivative, e to the power u means e to the power root x, and ddx of root x, right? Minus sin e raised to root x, e raised to root x, आणि root x चे derivative काय ते 1 upon 2 root x. This is the solution of a fourth one, isn't it? Now I will take the solution of a fifth one here. See, fifth problem. See, ddx of cos of tan of log x. Right? Now again if you observe this, this is u. Cos u चे derivative minus sin u, minus sin tan of log x. ddx of, again what is u? Tan of log x, right? Now minus sin tan of log x. Again where you have to substitute u, log x is equal to u. What is the derivative of a tan u? Sec square u means sec square log x, isn't it? Again you have to consider ddx of log x, and what is the derivative of a log x? That is equal to 1 by x. Therefore this is the solution of a fifth one, isn't it? Similarly I will take the ddx of the formula, that is tan x. See here, tan x What is the derivative of a tan x? That is equal to sec square x. Right? See the function here. ddx of tan of x square plus x plus 1. Right? Second, ddx of tan of x plus 1 by x. Again, third, ddx of tan of log of cos x. Fourth one, ddx of tan of cot cube x. Again, fifth one, ddx of tan of 1 by x. Right? See the again 5 problem. Right? Again, first one, solution of a first problem, ddx of tan of x square plus x plus 1. See, where you have to substitute u, x square plus x plus 1 is equal to u. Tan u ची डेरिव्हेटिव्ह काय येतं? tan x ची डेरिव्हेटिव्ह sec square x. Tan u ची डेरिव्हेटिव्ह sec square u means sec square x square plus x plus 1. Isn't it? Again, ddx of x square plus x plus 1. u ठेवून एकदा डेरिव्हेटिव्ह, u बरोबर जी आहे त्याची डेरिव्हेटिव्ह. अगेन sec square x square plus x plus 1. Here, what is the derivative of x square? That is 2x. And what is the derivative of x? 1. Right? Here, the solution of a first problem. Very simple. Right? What is the derivative of a tan x? Sec square x. But these are all 5 problems. That is nothing but the composite function. That is the combination of a algebraic, trigonometric, logarithmic, exponential. The different type of a combinations are there, and such a combination, it is called as a composite function. Again, I will take the second one here, ddx of tan of x plus 1 by x. Again, where you have to substitute u, x plus 1 by x is equal to u. Tan u ची डेरिव्हेटिव्ह काय येते? sec square u, sec square x plus 1 by x. Again, ddx of what is x plus 1 by x. Right? Here, sec square x plus 1 by x. Again, what is the derivative of x? 1. And what is the derivative of a 1 upon x? Minus 1 upon x square. Right? So, this is the solution of a second one here. Right? Again, the third one, see. See here, the third one, that is ddx of tan of log of cos x. See. Again, where you have to substitute u. Log of cos x is equal to u. Tan u ची डेरिव्हेटिव्ह sec square u means sec square log of cos x. Right? Again, ddx of log of cos x. Right? Now, sec square log of cos x. Again, here again you have to substitute u. Log u ची डेरिव्हेटिव्ह 1 by u means 1 upon cos x. And again, ddx of cos x. What is the derivative of a cos x? That is nothing but minus sin x. Therefore, sec square log of cos x. This you can write as a minus sin x divided by cos x. And again, if you simplify this, sec square log of cos x, that is sin divided by cos, it is nothing but tan, and minus tan x. Right? Therefore, your solution of the third problem is like this. Isn't it? Again, I will take the fourth one here, see. Fourth one, ddx of tan of cot cube x. Again, where you have to substitute u, cot cube x is equal to u. Therefore, tan u ची डेरिव्हेटिव्ह sec square u, sec square cot cube x. Again, ddx of cot x whole cube you have to write. Again, you have to use the power formula, sec square cot cube x. Now here again, u cube. What is the derivative of u cube? 3u square means 3 cot square x. Again ddx of cot x. Right? Now sec square cot cube x. 3 cot square x. Again, what is the derivative of a cot x? Minus cosec square x. Right? Here again you have got minus cosec square x. Therefore, the solution is minus 3 cot square x, cosec square x, and sec square cot cube x. Isn't it? So, this is the solution of a fourth one. Right? Now again, I will take the solution of a fifth one here. See, fifth problem. ddx of tan of 1 by x. See, again, where you can substitute tan 1 by x is equal to u. Tan u ची derivative sec square u. Sec square tan of 1 by x. Again, ddx of tan 1 by x. Right? Again, sec square tan 1 by x. Right? Now see, here you have to substitute u. Tan u ची derivative परत sec square u, sec square 1 by x, and again ddx of 1 by x. Right? Now sec square tan of 1 by x. Here again sec square 1 by x. And what is the derivative of a 1 by x here? That is minus 1 upon x square. Therefore, this is again the solution of a fifth one, and here I have considered as a formula tan x, it is equal to sec square x. The derivative of a tan x, that is equal to the sec square x. Now again I will take here sec x, cot x, and cosec x. Right? See, ddx of sec x. What is the derivative of sec x? Sec x into tan x. Right? Therefore, first one here, ddx of sec of x square root x. Right? Second one, ddx of, here you can take x square to x. Again, you can take here sec of x minus 1 by x. Right? Third one, ddx of sec of log of cot x. Again, fourth one, ddx of sec of tan x square. And fifth one, ddx of sec of x square a to the power x. Again take 5 problem. On this formula, that is sec x, the derivative of a sec x, that is sec x into tan x. Now I will take the first one. See, the solution of a first one, ddx of sec of x square root x. Isn't it? Again this you can write as a sec. The power of this function, that is equal to 2. And what is the power of x? That is 1 by 2. 2 plus 1 by 2. Again 2 to the 4. 4 plus 1, 5. Means here you can write x to the power 5 by 2. Isn't it? Now in this way, you have to convert the function like this. X square root x. Don't apply in the same way. Here don't apply the multiplication rule. Right? So to be very careful, here you have to make the power of x square and root x by the laws of indices. When the base is same, you can add the indices, right? So again you have to consider it as a u. Sec u ची derivative काय ते sec u into tan u means sec x to the power 5 by 2 tan x to the power 5 by 2 and ddx of x to the power 5 by 2, right? Sec x to the power 5 by 2 tan x to the power 5 by 2. Again, the power formula here. What you have to do? N into x to the power n minus 1 means 5 by 2 x to the power 3 by 2. Right? This is the solution of a first one, right? Now again, the solution of a second one, see, ddx of sec of x minus 1 by x, right? Again this you have to substitute as a u. Sec u ची derivative काय ते sec u into tan u, tan of x minus 1 by x, ddx of x minus 1 by x, right? Again sec x minus 1 by x, tan of x minus 1 by x. Again, what is the derivative of x? 1. And here what is the derivative of a 1 upon x? Minus 1 upon x square. Minus minus plus, that is 1 upon x square. Isn't it? This is the solution of a second problem. See here, the solution of a third one. See, ddx of sec of log of cot x. Again, where you have to substitute u here, log of cot x is equal to u. Sec u ची derivative sec u into tan u means sec log of cot x tan log of cot x and ddx of log of cot x, log of cot x, right? Sec log of cot x tan log of cot x. Here again, this is u, log u ची derivative 1 by u, 1 upon cot x. And again, what is the derivative of a cot x? That is equal to minus cosec square x, right? This is about the solution of a third one, right? Now I will take the solution of a fourth one here. See, fourth one. ddx of sec of tan of x square. Again, where you have to substitute u, tan x square is equal to u. Sec u ची derivative काय ते sec u means sec of tan x square. Again, sec u into tan u means tan of tan x square. Again, ddx of what? Tan x square, right? Sec u tan u means sec of tan x square, tan of tan x square. Here again sec tan x square, tan of tan x square, and here again u, tan u ची derivative sec square u, sec square x square, and here again x square ची derivative to x, right? This is the solution of a fourth one, isn't it? Now I will take the solution of a fifth one. See, ddx of sec x square a raised to x, right? Now see, here again this you have to substitute as a u. Sec u ची derivative sec u into tan u means sec x square a raised to x, tan x square a raised to x, and ddx of x square into a to the power x, right? Sec x square a raised to x, tan x square a raised to x. Here again you have to apply the product rule. See here the product rule. Again x square remain as it is. What is the derivative of a raised to x? A raised to x into log a plus a raised to x remain as it is, and what is the derivative of x square? That is equal to 2x, isn't it? So this is the solution of a fifth one, right? In this way we can take the problem on cosec and cot also, right? Now shortly I will take cosec and cot function. See here, cosec function, ddx of cosec x, that is nothing but minus cosec x into cot x, right? Again I will take here ddx of cosec 4 minus 5x d dx of cosec 4x plus 3 whole square d dx of cosec a to the power root x. I will take 3 problem only. See. Right? Again first one. d dx of cosec 4 minus 5x. Right? Again where you can substitute u. 4 minus 5x is equal to u. Cosec u ची derivative minus cosec u means minus cosec 4 minus 5x into cot 4 minus 5x. Again d dx of what? 4 minus 5x. Right? Here again minus cosec 4 minus 5x cot 4 minus 5x. Here the derivative of a 4, that is equal to 0. And what is the derivative of a minus 5x? That is equal to minus 5. Minus minus plus 5 cosec 4 minus 5x cot 4 minus 5x. Right? So in this way you can find out the derivative of this function again with the help of a chain rule, isn't it? So since there are the 15 formulas, therefore so many problems on what here? Chain rule, isn't it? Now suppose consider the second one, the solution of a second one, d dx of cosec of say 4x plus 3 whole square. See. Now where you have to substitute u? Here you have to substitute u. Cosec u ची derivative minus cosec u means minus cosec 4x plus 3 whole square cot 4x plus 3 whole square and d dx of 4x plus 3 whole square. Right? Again minus cosec 4x plus 3 whole square cot 4x plus 3 whole square, and again here you have to substitute u square ची derivative 2u means 2 4x plus 3, and what is the derivative of a 4x? Again याची काढायची परत 4x plus 3 ची 4x ची derivative 4 आणि 3 ची 0. Therefore 4 to the 8 minus 8 cosec 4x plus 3 whole square cot 4x plus 3 whole square, and here 4x plus 3. This is about the solution of a second one. Right? Now see the solution of a third one. Right? See d dx of cosec a raised to root x. Where you have to substitute? Again you can substitute a raised to root x is equal to u. Cosec u ची derivative minus cosec u into cot u and d dx of a raised to root x. Here again minus cosec a raised to root x cot a raised to root x. Again here you have to substitute u. A to the power u ची derivative a to the power u into log a आणि परत root x ची derivative 1/2 root x. This is about the cosec function. And the last I will take the cot functions here. What is the derivative of a cot x? The derivative of a cot x, that is minus cosec square x. Minus cosec square x, isn't it? So see here. Here again first one d dx of cot of 5 minus x square. Right? Second one d dx of cot of tan square x cube. Right? Third one d dx of cot of log of tan of log x. Right? Again fourth one d dx of cot of x cube e to the power x. Right? Now take the solution of a first one. Very simple. ddx of cot of 5 minus x square. Right? Where you have to substitute u? That is 5 minus x square is equal to u. Cot u च derivative minus cosec square u. Minus cosec square 5u minus x square. ddx of 5u minus x square. Right? Again, minus cosec square 5u minus x square. The derivative of a 5 that is equal to 0. The derivative of a minus x that is minus 1. And the derivative of a minus x square that is equal to minus 2x. This is the solution of a first one. Now I will take the solution of a second one. See here. Second, ddx of cot of tan square x cube. Again see, where you have to substitute u? Tan square x cube is equal to u. Tan u ch derivative minus cosec square u. U means what here? Tan square x cube. Right? Again, you have to find out ddx of, that is tan square x cube, you can write as a tan x cube whole square minus cosec square tan square x cube. Here again, this is u square ch derivative 2u, 2 tan x cube. Again, ddx of tan x cube. Right? U square ch derivative 2u means 2 tan x cube, and again you have to take ddx of tan x cube. Right? Again, minus cosec square tan square x cube. Here again, 2 tan x cube. Here again you have to substitute u. Tan u ch derivative काय आहे ते sec square u, sec square x cube, and at last what is the derivative of x cube? That is 3x square. Right? So this is about the solution of what here? Second one, isn't it? Now I will take the solution of a third one. See. Third, that is ddx of cot of tan of log x. Right? See. Where you have to substitute u? Again, tan of log x is equal to u. Cot u ch derivative minus cosec square u means minus cosec square tan of log x. Right? Again, ddx of tan of log x. Right? Now here again, minus cosec square tan of log x. Here again, you have to substitute u. Tan u ch derivative sec square log x. And what is the derivative of a log x? That is equal to 1 by x. Isn't it? So this is the solution of a third one. Now I will take the last, that is the solution of a cot. Isn't it? Cot x cube e to the power x. See, the fourth one. ddx of cot x cube e raised to x. Here again you have to substitute u. Cot u ch derivative minus cosec square u minus cosec square x cube e to the power x. Again, ddx of x cube e to the power x. Right? Now minus cosec square x cube e to the power x. Here again, what you have to do? Apply the product rule. X cube remain as it is. E raised to x g e raised to x. Again, e raised to x remain as it is. And what is the derivative of x cube? That is equal to 3x square. So here again, I have finished the sixth trigonometric function. Right? In the first span, I have taken, that is x to the power n, root x, and 1 upon x to the power n. The second span, I have taken, that is the sixth trigonometric formula, sine, cos, tan, sec, cosec, cot. Now which function remain here? Logarithmic function. See, again I will take the problem on chain rule of the logarithmic function. See here, logarithmic function. See, ddx of log x. What is the derivative of a log x? 1 by x, right? one simple one here. See, ddx of log x. Right? First, ddx of log of whole square. Third, ddx of log of x plus root of x square plus a square. Fourth one, ddx of log of sine of again log x. Right? Again fifth one, ddx of log of x to the base log x. Isn't it? See, log of x to the base log x. Right? So I will take these 5 formulas, 5 problems. Log x derivative 1 by x. Again, first one see here. ddx of log x. Here, where you have to substitute u? That is, log x is equal to u. Log u derivative 1 by u means 1 upon log x. And ddx of what? Log x. Here again, 1 upon log x. And the derivative of a log x, that is 1 by x. This is the solution of a first one. Now see, the solution of the second one. That is ddx of log x whole square. Right? Now here you have to substitute u. Log of log x is equal to u. U square derivative 2u means 2 log of log x. Right? Again ddx of, this is u square derivative 2u. Again ddx of log x. Right? 2 log of log x here again you have to substitute u. लॉगच्या समोर जे काय आहे ते u ठेवावं लागेल तुम्हाला. लॉग u ची डेरिव्हेटिव्ह अगेन 1 by u means 1 upon log of log x. Again you have to consider ddx of log x. Right? Now see here, 2 log of log x remain as it is, divided by log of log x also remain as it is, and again here you have to substitute u. Log u ची derivative 1 by u means 1 upon log x, and at last what is the derivative of a log x? That is 1 by x. So this is the solution of a second one. Right? Now the third one, see here, third problem. The solution of a third one, ddx of log of x plus root of x square plus a square. See this carefully here again. This is again u. Log u ची derivative 1 by u means 1 upon x plus root of x square plus a square. Right? Again ddx of x plus root of x square plus a square. Right? Now 1 upon x plus root of x square plus a square. Here again apply the addition rule. What is the derivative of x? X 1. Here again you have to substitute u. Root u ची derivative 1 upon 2 root u means 1 upon 2 root x square plus a square. Again, what is the derivative of x square? That is equal to 2x. And what is the derivative of a square? That is independent of x, considered as a constant, and the derivative of a constant function, that is always equal to 0. 2 get cancelled. Again, if you observe this, x plus root of x square plus a square. Here again, cross multiplied, root of x square plus a square plus x divided by root of x square plus a square. Again, if you observe this, the same term in the numerator and the same term in the denominator get cancelled. What is the result here? That is x square plus a square. Here you will get the short trick, right? Suppose you write x square plus minus a square. Again the answer is 1 upon root of x square minus a square. Suppose you write 4 here. Then what is the answer? 1 upon x square plus 4. Suppose you write 25. What is the answer? 1 upon root of x square plus 25. This is the short trick. तर हा एक तुम्हाला बंच इथे मिळून जातो, राईट. नाउ हियर द फोर्थ वन, सी फोर्थ वन, very simple again, d dx of log of sine of log x, right. See, where you have to substitute? Again, sine of log x you have to substitute as a u. Log u ची derivative 1 by u means 1 upon sine log x, right. Again, d dx of sine log x, right. Now here 1 upon sine log x, right. Here again you have to substitute as a u. Sine u ची derivative cos u, cos of log x, and again what is the derivative of a log x? 1 by x. So cos log x divided by sine log x, it is nothing but cot log x and divided by what here? X. This is the solution of a fourth one, isn't it? Now the last here, the solution of this, see. Here d dx of, I have taken log of x to the base log x, right. आत्तापर्यंत आपण असं बघितलेलं आहे, log x to the base a, where a is the constant and x is the function. What is the derivative? 1 upon x log a. But again, if you observe this, don't apply this formula here, because the base, it is one of the function. हा जो base दिलेला आहे, that is one of the function. Now you know the laws of logarithm, that is log of a to the base b, you can write as a log of a divided by log of b. असं लिहू शकता तुम्ही, right. Therefore, see, here this you can write as a d dx of log of x divided by log of log x, right. Now here you can apply the division rule. इथे कुठला रूल अप्लाय करू शकता तुम्ही? डिव्हिजन रूल. Now log of log x remain as it is. Take d dx of log x minus log x remain as it is. Take d dx of log x divided by log of log x whole square, right. Again log of log x. Here what is the derivative of a log x? That is 1 by x minus log x remain as it is. Again apply chain rule. इथे u ठेवा. log u ची derivative 1 by u means 1 upon log x, आणि परत log x ची derivative 1 by x divided by log of log x whole square, right. Again if you observe this, this get cancelled. When the denominator is same, you can directly add the numerator, and here you have got the result, that is log of log x minus 1 divided by what here? X, and divided by this log of x whole square, right. So this is the result, isn't it? So this is about the logarithmic function, isn't it? Now I am going to take the exponential functions here. See, d dx of e raised to x, that is equal to e raised to x, and d dx of a raised to x, that is equal to a raised to x log a, right. Now I will take the formulas here. I will take the problem on exponential function. See, first one, d dx of e raised to e raised to e raised to x. Second one, d dx of e raised to sine cube root x. Again third one, d dx of e raised to log of sin square x plus cos square x. Again, fourth one, d dx is equal to 4 to the power sin x, 4 to the power log of sin x to the base 2 plus 9 to the power log of cos x to the base 3, isn't it? And fifth one, d dx of again 16 to the power log of sec x to the base 4, and here again minus 25 log of tan x to the base 5, isn't it? So these are the 5 problems here. Again, these are the very important. Right? Now the first one, the solution of a first one, that is d dx of e raised to e raised to e raised to x. Right? Now where you have to substitute u? This is the base. This e you have to consider as a base, and e raised to x, it is the power. Therefore here you have to substitute u. E raised to x, it is the power, and there you have to substitute u. E to the power u is derivative e to the power u. See? And d dx of e raised to x. Again, e raised to x. Here again you have to substitute u. E to the power u is derivative e to the power u. This is u. And again you have to take d dx of e to the power x. Again, e raised to x. E raised to x. Again, e to the power x derivative e to the power x. Isn't it? So, this is about the first one. First problem, that is the first solution, isn't it? Now see the second one. d dx of e raised to sin cube root x, right? Again, what can you do? This you have to substitute as a u, right? Then e to the power u derivative e to the power u, e to the power sin cube root x, and d dx of sin root x whole cube. Right? Now e raised to sin cube root x. Here again you have to substitute u. U cube derivative 3u square, 3 sin square root x. Again d dx of sin root x. Right? Now again e raised to sin cube root x, 3 sin square root x. Here again you have to substitute u. Sin u derivative cos u, cos root x, and the d dx of root x, it is nothing but 1 upon 2 root x. Right? So this is about the solution of a second one, that is e to the power sin cube root x, e to the power u derivative e to the power u, d dx of sin root x whole cube. Again you have to substitute u. U cube derivative 3u square means 3 sin square root x. Again you have to consider d dx of sin root x. Here again you have to substitute u. Sin u derivative cos u means cos root x. And what is the derivative of a root x? That is 1 upon 2 root x, isn't it? Now again see here. Here you should know the formula of a logarithm. Here say, suppose a and the power is log of y to the base a. Now when this base is same, this base and this base is same, all this term get cancelled, and what is remain here? Y. Why? Because see, you know the definition of a logarithm. Do you know the definition of a logarithm? See, here, if a raised to x is equal to y, if your problem it is in the form of a indices, indexच्या form मध्ये असेल तर how will you convert in the logarithmic form? If a raised to x is equal to y, then you can write log of y to the base a, it is equal to x. This is first and this is second. See, if a raised to x is equal to y, then log of y to the base a, it is equal to x. Now you can substitute this value x from second in first. ही x ची व्हॅल्यू सेकंड मधनं काढा आणि इथे वर 1 मध्ये पुट करा. Therefore a चा power, what is x here? Log of y to the base a, it is equal to what here? Y. So what is the meaning of this here? A to the power log of y to the base a, it is equal to y means all this term get cancelled and this is y remain y, isn't it? So here also you have to apply the same concept for the third problem, that is d dx of e raised to log of sin square x plus cos square x. See, now whenever the base is not given, that means the base is e. When the base is e, that means we are using the natural logarithm. And whenever we are using the natural logarithm, it is need not to write the base. Whenever the base is not given, that means we have to ourselves understand that the base is e, where e is the any irrational number and whose approximate value is 2.7182, isn't it? Now here the base is not given. That means the base is e. That means we are using the natural logarithm. There are the two type of a logarithm. One is the natural and another is the common logarithm. What do you mean by the natural logarithm? When the logarithm having the base e, it is called as a natural logarithm. Means whenever you are not going to write the base, that means we are using the natural logarithm. But whenever the base is 10, then that is called as a common logarithm. And that common logarithm you generally used in physics and chemistry, isn't it? So when the base is 10, that is the common logarithm, and that you can use in physics and chemistry. Here we are using, in pure mathematics, we are using always the natural logarithm. Here the base is not given, that means the base is e, isn't it? So the base is e here, this also base is e. All this term get cancelled and what is remain here? d dx of sin square x plus cos square x. Now you know the identity, that is d dx of sin square x plus cos square x, it is nothing but 1, and the derivative of a constant function, it is always equal to 0, isn't it? Now here the next one, see here, if you observe this, the fourth one. See the fourth one, this is also very very important for the MCQ. 4 to the power log of sin x to the base 2 plus 9 to the power log of cos x to the base 3, right? Now see, how will you do this? Now don't put u, 4 to the power u, that is a to the power x derivative, a to the power x log 2, right? That is little bit complicated, that is very complicated. So here you have to use the different trick. 4 you can write as a 2 square, isn't it? 4 you can write as a 2 square. The power is log of sin x to the base 2. Here 3 you can write as a 3 square, and the power is log of cos x to the base 3, right? Again, you know the power, suppose a to the power m whole to the power n means power, it is multiplied to the power a to the power mn, isn't it? Therefore here this also, this power and this power get multiplied, means 2 to the power 2 log of sin x to the base 2. Here also power is multiplied to the power, means 3 2 log of cos x to the base 3. Again you know the rule of a logarithm, log of a raised to m, this power you can multiply here, that is m log a, राईट. हा जर पॉवर इथे असेल तर हा इकडे मल्टिप्लाइड होतो आणि इथे असेल तर वर मल्टिप्लाइड होतो, वर पॉवर येतो. ठीक आहे. इन द सेम वे डी डी एक्स ऑफ सी हियर यू हॅव टू मेक द ब्रॅकेट अगेन दिस पॉवर come to here, that is 2 to the power log of sin square x to the base 2. Again here also 3. This power comes to the head power of what here, cos square. Here becomes cos square. Therefore 3 log of cos square x to the base 3. Sorry, 3 to the power log of cos square x to the base 3. Right. Again, आत्ताच सांगितलं आपण, when this base and this base is same, all this term get cancelled and what is remain here, sin square x. Here also this base and this base, it is same, what is remain, cos square x. And you know d dx of sin square x plus cos square x, that is always equal to 1, and the derivative of a constant function, it is always 0. Now see the last one here. See, again these are the very very important examples of the chain rule. This is useful for the MCQ also. And here again, ddx of, see, 16 to the power log of sec x to the base 4 and minus 25 log of tan x to the base 5, right? Now again, don't apply the chain rule, don't substitute u, right? Here again you have to use some trick here. This, here again, ddx of 4 you can, 16 you can write as a 4 square, whole to the power log of sec x to the base 4. Again, 25 you can write as a 5 square, whole to the power log of tan x to the base 5. Again, power it is multiplied to the power, therefore ddx of 4 raised to 2 log sec x to the base 4 minus 5 2 log tan x to the base 5, right? Again see, ddx of 4 raised to log of 2 comes here, right? 2 log of sec square x to the base 4. And here also, by the rule of a logarithm, again log of, this you can write as a tan square x to the base 5. Again, you know the rule. When this base and this base is same, this base and this base same, all the term get cancelled. What is remain here? Only sec square x. And here what is remain? Tan square x. Again you know the identity, that is 1 plus tan square x. It is equal to sec square x. Therefore, sec square x minus tan square x, it is equal to 1. Therefore, ddx of sec square x minus tan square x, it is equal to 1. And again the derivative of 1, it is equal to 0. So, I have taken all the problem on the chain rule, on all the formulas, isn't it? I have taken the exponential, I have taken the logarithmic, I have taken the algebraic, and again I have taken the power formula, that is x raised to n, 1 upon x to the power n, also root x, isn't it? Again it is remain to take the problem that is an important problem from the chain rule. Again, that is very, very important problem. So, all that problem I will take in the next video. That problem, these are the very, very important, right? And the title is, I am going to give the title always as an important example from the chain rule. So, the student, if you like my video, then share it and subscribe my channel.